Hi, and welcome to this special edition of AWS Innovate 2018. Thank you for tuning in to this presentation where we will discuss how you can take the machine learning models that you've trained in the cloud to the edge, closer to your data and your use case. I'm Timothy Cruz, APAC Solution Architect focusing on IoT. Before diving into the edge itself, it's important to understand what the edge means and how you can address connectivity, security, and data management in remote locations. For that, we'll go over a bit of background on the Internet of Things and the services that we have been working on at AWS to help our customers address connecting their devices. We will cover the AWS IoT suite of services, but also AWS Greengrass, who will be a core component of running machine learning models at the edge. We'll also discuss the reasons why you would want to run your models closer to your data rather than rely exclusively on the cloud. Finally, the Internet of Things isn't complete without things, so we'll go over a short demo running on AWS Greengrass that will showcase a simple use case of using AWS Greengrass Machine Learning Inference to perform ML inference locally on a device. So let's dive right in. With the growing need of security in connected device at scale, we introduced AWS IoT 3 years ago. A fully managed service simplifying and removing a lot of the heavy lifting around connecting devices to the cloud. The AWS IoT service was designed around the following key functionalities. Security. We decided to set a high bar with TLS 1.2 encryption of the data to and from the devices, and mutual authentication backed by X509 certificates. Connectivity to the cloud. The service supports multiple open source protocols, of which MQTT, which is a low bandwidth, very efficient publish-subscribe protocol designed for connected devices, but also supporting HTTPS and WebSockets. Connectivity to all the AWS services. With a built-in rules engine, data being transferred through the AWS IoT Device Gateway can be filtered and routed to other AWS services. For example, storing the data directly into a DynamoDB table, dumping it into an Elasticsearch cluster for searching and dashboarding, or the Lambda functions opening up to more calculations on the data and passing on to outside APIs. Offline interactivity. With device shadows, AWS IoT maintains a copy of the state of the device even when non-connected, allowing applications to query but also interact with the devices to change their state, without the need to actually have to interact with the device directly. And finally, as you would expect, a very scalable and highly available service customer could rely on to build their IoT-based solutions. We have been seeing great successes from customers around the world leveraging AWS IoT for their use cases, from iRobot's automatic robot vacuum cleaners or globally distributed air filtering system by Manhummel. But some use cases were still tough to address because of the specific or extreme conditions in which they operate. This is why in 2016 we introduced AWS Greengrass, addressing the complexities of the edge. AWS Greengrass is software that we provide. You can run it on embedded Linux devices or even full-fledged servers if you wish. The AWS Greengrass service provides the following functionalities. The same level of security you'd expect from AWS services with TLS encryption and the same certificate-based authentication. An MQTT broker allowing IoT connectivity locally between your devices and using Greengrass to route your data back up to the cloud. Local device shadows to control the state of your connected device locally. And one of the best functionalities, local Lambda functions, allowing you to run the same Lambda functions you are used to building in the cloud on your edge device. AWS Greengrass is a great platform for dealing with the constraints of the edge, allowing customers to make meaningful sense of their data, act on it in real time without the need for cloud connectivity. Rio Tinto, for example, have been leveraging AWS Greengrass in their very extreme mining environments, where data connectivity is very difficult. Using AWS Greengrass, they are reducing the wear and tear of their very expensive truck tires, by monitoring vibrations of their trucks around the mine site, they can map road deterioration to send teams to flatten out the damaged roads. Doing this on-site at their mine sites without the need for connectivity back to the cloud. Listening to our customers even further, we complemented our IoT portfolio of services at re:Invent last year to further support their use cases. AWS IoT Device Management helps our customers manage their fleet of devices at scale, with features like onboarding of fleets of devices, software updates, and better management. AWS IoT Device Defender, available later this year, improves security at the fleet level for IoT by detecting fraudulent behavior over a fleet of devices. AWS IoT Analytics simplifies the ability to run sophisticated analytics on massive volumes of IoT data. Amazon FreeRTOS, an operating system for much smaller devices, facilitating cloud connectivity for lower-powered devices or typically microcontrollers. And finally, AWS IoT One-Click, which helps customers in need of IoT for very simple action-based use cases, and for which IoT may not be a core part of their business, providing the means to simply provide business actions with a one-click button execution. With all the new functionalities and services around AWS IoT, customers can manage fleets of devices securely and start creating insights and control of the data they are managing. However, customers have been asking us to extend intelligence to the edge. The cloud is the logical placeholder for intelligence and deep learning. Being able to leverage the almost infinite amount of cloud capacity to create the most complex and efficient models. But what if I need this intelligence at the edge? In order to achieve this, we took the Greengrass platform, already great for running local actions and local triggers, state managements and security, and we improved it by adding over-the-air updates for further management of devices out in the field, support for more industry protocols like the OPC UA with more protocols coming, and local resource access within your Lambda functions, allowing customers to access their hardware from their Lambda business logic. And these three key pieces were core to us being able to deliver the functionality we wanted: local machine learning inference in Greengrass. Why does this make sense? Machine learning inference at the edge has numerous use cases for all industries. Whether in self-driving cars, where you want to detect everything happening in front and around the vehicle, understand the images and drive more safely. Or video surveillance, where you require detecting shapes, forms, people in a video feed in real time and be able to take action. Analyze sound, recognize patterns in very noisy environments. In robotics and manufacturing, machine learning can help improve how robots detect shapes or move around to improve efficiency. For example, in the agricultural space, customers like Blue River Technology are using machine learning and AI to improve the efficiency of how they spray fertilizers on the plants. Why spray whole fields when you could spray only the plants in need? Optimization, yield improvement, and working towards better and smarter agriculture. The use cases are limitless. So we tried to understand the problem statement around bringing machine learning at the edge. In machine learning, models are typically built and trained in the cloud, and then run in the cloud on incoming data. With Greengrass Machine Learning Inference, we are leveraging the cloud for its infinite computing capacity to build and train our models. But then, we package and deploy these models and frameworks on our target edge devices running Greengrass. This enables running our models on our devices without the need for connectivity to the cloud, staying close to our data. And with this ability, being able to take action on the data and the inferred responses in real time. The benefit of leveraging Greengrass Machine Learning Inference allows for developers and scientists to build and train their models repeatedly in a cycle, deploy them, test them, retrain them in the hope of creating smarter models for their use cases. By keeping the training and building of the models in the cloud, they are not constrained by the limits of their edge devices. This allows customers to derive great value from machine learning inference at the edge. Whether because of latency requirements, some data needs to be processed as soon as it is generated. The processing cannot wait for the transfer to the cloud and back down onto the device to make decisions. Calculations need to be executed as close as possible to the data itself. Some use cases generate extreme amounts of data, and given physical networking capabilities at the edge, transmitting all that data would become very expensive to support. Some use cases don't always have internet connectivity, requiring the ability to make sense of the data without that vital connection to the cloud. Finally, privacy. Some data just cannot be transferred from one location to another. And we are already seeing great customer use cases leveraging Greengrass machine learning inference. Sony has been using AWS Greengrass for its manufacturing requirements. And now, with Greengrass machine learning inference, they are improving their manufacturing processes by optimizing their local factory worker positioning. They are also using AWS Greengrass machine learning inference for predictive maintenance of their machinery. They have seen great value in the ability to customize their machine learning models without sizing limitations, as well as being able to address high-frequency sensing and anomaly detections in their machineries. Nokia is leveraging Greengrass at the edge for machine learning inference for their video analytics solution. By being able to run their machine learning models right on their cameras, Nokia are able to detect anomalies in traffic and improve the functionalities of their traffic cameras. Video is very demanding, and in tough networking, latency, and bandwidth environments, AWS Greengrass machine learning inference has enabled them to reduce the amount of necessary data needing to be sent back to the cloud significantly. Now, machine learning can be hard. There are multiple steps. First of all, you need to collect and move your data to the cloud. Process that data, then build and train your models. Once your model is ready, you need to deploy your model on your devices. Whilst you're trying to get your model and training right, this is a very repetitive process, and until now, this could be very difficult to achieve. A very manual process because of the lack of managed services to support optimizing your training and getting it into your devices. Then, once you've deployed, you also need to package and provide the specific framework to run your models, like MXNet, TensorFlow, Caffe, etc. You need to write your wrap that will leverage your framework and models, but also manage its deployment. Finally, you may need to access hardware capabilities of your device to improve the performance of your inference. This is why Greengrass machine learning inference helps facilitate most of these steps. Whatever the case, you start by training your models in the cloud. We think the cloud is the best place to operate your training because of the massive amount of computing power at your disposal. Also, with unlimited storage capabilities, you can store very large amounts of training data. Then, by deploying your models to your devices, you can benefit from improved latency by being as close as possible to your generated data, reduce bandwidth requirements. You don't need to send all your generated data. You can filter or just send the results from your inference. Or you may simply benefit from being able to support your use case where your data cannot leave that physical location. Installing AWS Greengrass on your device will tie everything for you and simplify the management of deploying your models and application code on your device. Your trained models and application via Lambda functions get deployed onto your device. Then, as your devices generate data, you can trigger your Lambda functions locally and make inferences on that data. This allows you to sense, infer, and take action in real time on your data, locally, at the edge, on your device. Finally, you retain the total flexibility to send data back to the cloud. You can use Greengrass to filter out the noise from the data and only set the relevant samples, or you can send the results from your inference. Combining your inferred results with filtered data, you can also use this as a way to improve your models further by training your models again to redeploy updated versions. Let's have a quick look how this works and looks within the AWS Management Console. Again, first you need to train your model, and to do that, you can leverage your own training systems or simply use Amazon SageMaker. It's a great managed service to help facilitate the training and creation of machine learning models. Note that if you want to understand Amazon SageMaker better, do tune into the sessions from my colleagues on that subject. From an AWS Greengrass perspective, you start by creating a machine learning resource within your Greengrass group. You provide your model to that resource. This model can be one you already have and provide via an S3 bucket, or you can simply use the output of a SageMaker trained model. If you need hardware access for your calculations, you can access local hardware accelerators or specific hardware of your choosing. You specify the local resources your Lambda functions and models may require. For example, accessing a GPU or FPGA to speed up the inference. No specific code is required. This is set up within the Greengrass configuration. In this example, we're using an NVIDIA GPU by creating a local resource on /dev/NVIDIA/GPU0. Finally, as discussed, packaging your frameworks for your specific devices and getting them to work properly on your hardware is not trivial. So we've helped simplify this by providing MXNet packages pre-built and ready to download for a subset of hardware platforms. The Apollo Lake and NVIDIA Jetson platforms, as well as Raspberry Pi. Of course, you can also choose to build your own framework yourself if you choose. And it's not limited to MXNet. We've just made it a bit easier for you by providing the pre-compiled libraries for you to use. With all that, you're ready to go. A great example of a product leveraging AWS Greengrass Machine Learning Inference is the AWS Deep Lens. We introduced the Deep Lens at reInvent last year, and customers will be able to purchase it later this year. Built in partnership with Intel, leveraging Atom processors with Apollo Lake architecture and AWS Greengrass, the AWS Deep Lens is a video camera that runs computer vision models. You can build your own image recognition models and deploy them directly on the Deep Lens device. A great way to get started easily. Do look out for its availability on Amazon.com. To wrap up this presentation, I thought I'd run through a small demo with you. If you don't yet have a Deep Lens device, why should that stop you in building your own small connected camera and start recognizing objects? So let's build our own. So for this demo, I'll be using a Raspberry Pi, the Raspberry Pi camera, and the Raspberry Pi SenseHat. I'll be setting up multiple local resources to use my camera within my Lambda functions. To use my camera, I'll connect to /dev/vcsm and /dev/vchiq. And to use the SenseHat, I'll connect to /dev/fb1. As you can see, I'm only using the Pi SenseHat for its LEDs. Of course, I'll be using AWS Greengrass Machine Learning Inference to detect objects in my images. For this, I'll be using a SqueezeNet model. SqueezeNet is a lower footprint model requiring less parameters whilst maintaining a high enough accuracy. It's a great model for low-power devices like the Raspberry Pi. And since my Raspberry Pi doesn't have a GPU, it's a great fit. So let's switch to my AWS Management Console for AWS Greengrass. This is the AWS Greengrass console. From here, you'll start defining your new Greengrass cores, groups, and devices. I've already created a group for this demo, so let's go have a look. As you can see, I already have multiple Greengrass groups for projects I've been working on. The Greengrass group defines a Greengrass configuration. In a way, it packages all the IoT resources that are part of a Greengrass deployment. Let's have a look at my Innovate 2018 group. The management console for my group shows the following. First, I can see all the deployments I made to this Greengrass group. As you can see, I've been quite busy deploying numerous times, effectively trying to get my model and demo to work. Each deployment is a package that will contain my Lambda functions, my machine learning models, and all configurations intrinsic to the Greengrass group. I can see the subscriptions, cores, devices, Lambda function, and resources specific to this group. For this presentation, let's have a look at the basics for now. Let's have a look at my Greengrass cores for this group. In a group, you'll define the first device, the Greengrass core. In my group, I only have one core. If we look at its details, you can see it actually is an IoT device or thing. It will have its own AWS IoT X509 certificate. The Greengrass core has its own shadow, and you can interact with it the same way you would as a normal AWS IoT thing. The connectivity information provides details on how a device locally within a group could reach the Greengrass core on the local network. Coming back to my group, you can also define within your group any other potential IoT devices that you want to connect to the Greengrass core. In my demo, I don't have any other devices. I'll only be leveraging the Greengrass core device. Before having a look at the Lambda configuration, let's have a look at the resources that I've configured for this group. This page will list all of the configured local resources from my Greengrass group. For this demo, I've set up multiple resources, 3 device resources and 1 model resource. The 3 device resources refer to the 3 different peripherals or hardware devices on my Raspberry Pi. If, say, I wanted to use a GPU, this is where I would declare its configuration and source. For the demo, I'll be using the SenseHat device, which is located on /dev/fb1, and the camera, which is located on /dev/vchiq and /dev/vcsm, for the video interface and video share memory respectively. Basically, these are the Linux device files I will need to read and write to in order to interact with my hardware peripherals. Let's have a look at my model resource. Here, I've defined a machine learning resource. You can select to bring your own pre-trained model by storing it in an S3 bucket, or you can provide a training job source using Amazon SageMaker. If I select the training job source, we can select the training job from my SageMaker jobs. For the purpose of this demo, I'm using my pre-trained model and I'm loading it from S3 bucket. Then I need to select a local directory on my device where the model resource files will be extracted to. Note that these will be tied to the context of the Lambda function using that resource. And this is a great segue to having a look at my Lambda functions. You can see here I have 2 Lambda functions. They serve 2 very different purposes. Note that these Lambda functions are actually stored and managed from a versioning and aliasing perspective in the AWS Lambda Management Console. These are the same Lambda functions you are accustomed to writing and managing. The only difference is where they will actually be running and how. My first function, the Greengrass Object Classification 4 function, is the Lambda function that will be doing the inference on my images by using my SqueezeNet pre-trained model. You can configure your Lambda functions to run indefinitely or triggered on demand. This function runs indefinitely. We will be analyzing the video stream 1 image every 30 seconds. So we'll let it run all the time. No need to trigger it on demand. If we look at the resources this Lambda function is using, you can see I've associated 3 of the resources we declared in the previous step. I need my Lambda function to access the 2 video camera device resources and the SqueezeNet model resource. With these 3 resources, my Lambda function can easily start capturing images from the video feed and send them to the model for image recognition. Now, my second Lambda function is the very simple Lambda function that will act on the recognized information from the first Lambda function. This function does not run indefinitely and is triggered on demand. I want this function to parse the inferred results and trigger the LEDs on my Raspberry Pi SenseHat. As you'd expect, for this demo, I'll connect this Lambda function to my SenseHat device resource. If my model detects a coffee mug, then I want my LEDs to turn blue. If not, they should stay red like they are now. It's a simple demo to showcase how you can act on your data at the edge on inferred data. No need for internet access. You can act in real time. All the sensing, inferring, and acting on the data is happening locally on my Raspberry Pi. Last bit we need to look at is connecting everything together. We need to define our subscriptions. This tells Greengrass how the data gets connected from one Greengrass resource to the next. I've written my recognition Lambda function, the Greengrass Object Classification 4 function, to publish the results of the inference on the Innovate 2018/Inference MQTT topic. So I've created a subscription that tells my SenseHat Lambda function to subscribe to that topic with my recognition Lambda function as its source. This will allow for the recognition results, the inferred information, to be passed to my LED function. If my model recognizes a coffee mug, go blue. Okay, so once all of this is properly configured, I can simply deploy onto my device. For the interest of time, I've pre-deployed this configuration. So let's have a look at the incoming data. Since I'm running inference at the edge, I'm actually not sending the data back to the cloud. So let's log into my Raspberry Pi to look at what my Lambda function is receiving. As you can see from the feed, my demo sends data every 3 seconds. And the laptop I've placed in front of the scene is being detected, here called the notebook. Small disclaimer here, my model isn't perfect. Depending on the scene in front of the camera, the model is detecting some pretty obscure shapes with pretty low probabilities. The probabilities aren't great for those detections, showcasing I may need to train my model a bit more in order to get better results. This is a great case for leveraging SageMaker to improve my model. For now, this will be enough. All I'm trying to do is detect the presence of a coffee mug. So what happens if I place my coffee mug in the scene? There it is. My LEDs have turned blue, and we can see from the feed that we have detected a coffee mug, this time with a small probability. If I remove the mug, we should turn back to red. Great, it works. So there it is. As you saw from this simple demo, Greengrass Machine Learning Inference allows you to simply deploy your models onto an edge device and start acting on the inferred data. I've been trying to detect a coffee mug, but imagine what else you could detect and the different use cases. Maybe you'd like to recognize faces at the edge or detect types of objects you do not want to see in a secure location. Use cases are infinite. I'm curious to know what you will build with Greengrass Machine Learning Inference. And I hope this session enabled you to understand the service better. After today, if you want to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use practice exams to help you prepare your AWS certification. Finally, thank you for attending this session today and sticking it out until the very end of the presentation. Please take the time to provide feedback on today's event so that we can improve the event experience for you in the future. Thank you.